one is about operations with fractions. We're going to learn how to add, subtract, multiply, and divide fractions and mixed numbers. Let's start with addition, subtraction of fractions. And it's easier if we just grab an example, and let me kind of walk you through this. The first rule and the biggest rule is that when you add or subtract fractions, you must have a common denominator. Now on this one, I already have that, okay? So that's a hurdle we're going to look at later. But for now, let's just look at this. And I know you could do this in your head, so just play along with me. I want you to focus on the process right now, not the numbers, okay? Since I have a common denominator, well, let's look at what this fraction means. If you can think of a fraction as starting off as a whole pizza, everybody knows what a pizza looks like. And somebody came along and they cut this pizza into different pieces. How many pieces? That's what the bottom number tells you. It tells you how many pieces that original pizza was cut into. So here, there was a pizza and somebody cut it into 5 pieces. Okay, there were 5 pieces to start with. So if I drew a picture of what this problem looks like, here's 3 pieces of the 5, and somebody wants to take away one of those pieces. So what do you have left? Well, you're going to have 2, and what size are the pieces? Well, they're still the 1/5 of a piece of a pizza. They're still 1/5 size. So your size did not change. Your denominator did not change. The only thing that changed was how many of those pieces you have. Okay? So let's look at one now that does not have a common denominator. Let's try 1/5 plus 2/3. Now these pieces are different sizes. This is why you need to get them to a common denominator. You need to cut your pieces up and stick some pieces together, whatever you have to do, but you're trying to get the pieces all the same size. That way you can put them back together or you can take away. Look for a number that both of these numbers will go into. This one's an easy one. Like I said, we're focusing on the process, not the numbers. The smallest number that both of these will go into is 15. So I'm going to make 2 new fractions, equivalent fractions out of these, using manipulation. That's what you learned in lesson 4. So if you have trouble with this, pop back to lesson 4 and see about fraction manipulation. Now I want this fraction here to be equal to my first fraction here. What did I do to my old denominator to get the new one? Well, I multiplied it by 3. So I've got to multiply the numerator by 3. That's going to give me 3/15. Okay. Now I ask myself, what did I multiply this denominator by to get my new denominator? Well, I multiplied it by 5. So I'm going to multiply the numerator by 5. 2 times 5 is 10. Now, I've effectively chopped up these pieces into more pieces, but they're all the same size now. So all I have to do is add the numerators. 10 plus 3 is 13. Now remember, the size of your piece didn't change. So your denominator is not going to change when you add or subtract. Okay? Now, let's look at one more example. Let's take 1/4 plus 1/6. And I want to prove a point to you with this one. I hear people all the time tell me, well, you multiply the 2 denominators together to get your common denominator. You can do that. That works every time. So let's look at what happens when we do that. If I multiply 6 times 4, that's going to be my new denominator, 24. Go back and ask yourself, what did I multiply this by to get 24? Well, times 6. So my new numerator is 6. What did I multiply this old denominator by? Well, by 4. Multiply the top by 4. Okay. Now, you get 10/24. Now, remember, I told you, you always have to leave your denominator in lowest terms. There's a number that'll go into both of these, and it's 2. So if I reduce this down, I'm going to get 5/12. Okay? Now, watch this little trick. If I had used my head right here, and I'm going to erase these. Well, yeah. Let me just copy the problem over. I'm starting over. If I had used my head right here and said, what's the smallest number that both of these will go into, I would have come up with 12, right? So watch what happens if I start off counting a common denominator of 12. Same thing. What did you multiply 4 by to get 12? Well, you multiplied it by 3. So you got to multiply the numerator by 3. So you get 3/12. What did I multiply this old denominator by to get the new one over here? I multiplied it by 2. So I've got to multiply the top by 2. Now, look what happened. My fractions are smaller. So now when I add across the top, I still get 5/12. I still get the same answer. I just didn't have to reduce. So it saved me a step. This is technically the way you're supposed to do it. But, you know, sometimes I just don't have time or energy to think that hard. If you multiply these two together, you will get a common denominator. You may not get the lowest one, but you'll get a common denominator, and then you can reduce it down at the end. It all comes out in the wash, okay? Now, one more little thing that you may run into is a whole number minus a fraction. Remember, any whole number is equal to itself over 1. So if you have a whole number that's trying to interact with fractions, I don't care if it's add, subtract, multiply, or divide. If you've got a whole number stuck in there that's trying to play with your fractions, then fix it. Change it to a fraction. Put it over 1. Now you're ready to proceed as usual. The common denominator between these two would be the 5. So what did you multiply this by to get 5? So you got to multiply the top by 5. Same thing here. You multiplied this by 1, so you got to multiply it by 1. Didn't change. Now 15 minus 1 is 14/5. You could leave it like that, or you can change it to a mixed number. Ask yourself, how many times will 5 go into 14 evenly? 2 times. That's 10. And 14 minus 10 leaves you 4/5. So that would be mixed number. Okay, now for multiplication. This is the easiest part of working with fractions. When you multiply, you do not need a common denominator. All you need are some fractions with a multiplication sign. When you multiply fractions, you just multiply numerator times numerator and denominator times denominator, and then reduce. 2/15, there's nothing to reduce. And that's all there is to it. If there are different ways to write multiplication, that's one of the trickiest parts. You can have the little X that means multiply. This could have been written separated by parentheses, or you might see a dot. All 3 of these ways still mean multiply. And that's all there is to it. Numerator times numerator, denominator times denominator, then reduce. Okay? So now let's look at division. Division is actually not much harder than multiplication. Let's take 6/7 divided by 1/2. The way you divide fractions is keep, change, flip. Okay? You keep the first fraction just like it is. You change the sign from division to multiplication, and then you flip the fraction. So we're going to rewrite this as 6/7 times 2/1. Now you have a multiplication, so all you're going to do is multiply all the way across the top, all the way across the bottom, and this is lowest terms. There's not a number that goes into both of these. If you want to change it to a mixed number, you can. 7 will go into 12 one time. 5/7 left over. Okay? Or you can leave it improper. Now, there are different ways to write division, just like I showed you with multiplication. This could be written 6/7 over 1/2. That means division. Now, same thing, if you get a whole number interacting in your division, just put it over 1. If I have 2/3 divided by 4, then make it 2/3 divided by 4 over 1. Then you're ready to keep, change, flip, okay? And multiply that as usual. Now, that's how to add, subtract, multiply, and divide all the fractions. Now let's look at mixed numbers. What to do if you have a mixed number? Well, you're going to recognize it first because it's going to be a number and a fraction. Whether you add, subtract, multiply, or divide, change this to an improper fraction and then do it just like we looked at how to do all those other operations. That is the easiest way. There is no need to try to keep up with letting whole numbers interact with whole numbers and fractions with fractions and jumble it all up. Just change those mixed numbers to an improper fraction and then do them just like you were working with the other ones. Then when you get to the end of the problem, reduce it down, change it back to a mixed number if the instructions tell you to leave it as a mixed number. But, you know, that's the best way. Just change it to an improper fraction. And if you'll remember, you do that by multiplying denominator times whole number. 2 times 3 is 6. Plus 1 is 7. So this would be 7/2. And then you're good to go. There is a worksheet that goes along with this lesson. There are 40 problems. It's a lot because I really feel that this is significant. I have seen so many students that start fumbling when we get to algebra because they're not secure in how to work with fractions. When you start putting variables in here, you don't need to be thinking about the process anymore. That's when you start thinking about the numbers. So do this worksheet with no calculator. Out beside each problem, there's a blank to the left. I've jumbled all these up. I didn't separate it into sections about here's your addition, here's your subtraction. You're going to have to determine what you need to do. Analysis of a problem is something we don't really teach too much anymore. We separate it out for you when we give an assignment. Like, here, all of these are this kind of problem, so do them all this way. No, you need to learn to analyze your own problem. So out to the left, there's a blank, and you're going to put an A, a D, an M, or an S for addition, subtraction, multiplication, division. Look at your problem, figure out what am I being asked to do, and put that letter out to the left. Then you put your answer in the blank out to the right. Okay? So good luck with this. I know you can do it. Just keep on plugging through. We're almost through with the basics and ready to get into algebra. So keep on working, and I'll see you in lesson 6.